All right, let's talk about one of the coolest and most fundamental tools in data science, k-means clustering. This is an algorithm that literally finds hidden patterns in the chaos of the world around us. And today, we're going to break down exactly how it pulls that off. I mean, think about it. How do you find order in a sea of data? It's a massive challenge for pretty much everyone, from huge tech companies down to a single person trying to make sense of a spreadsheet. We are absolutely swimming in information, but raw data? It's mostly just noise. The real trick is finding the meaningful signal inside all of that static. And this isn't some abstract theoretical problem. This is real life. An online store has millions of customers, each with their own weird buying habits. A news site has to sort through thousands of articles popping up every single hour. Heck, even one single photo on your phone is made of countless tiny colored pixels. How on earth can a machine start to make sense of all that chaos? Well, that is where our star of the show comes in. K-means is like an automatic organizer. It's an algorithm specifically designed to step into that messy, chaotic data and just create order. So what is it really? Well, to put it simply, k-means is an algorithm that automatically groups similar things together. That's it. The K in the name, that's just a placeholder for the number of groups you want to find. The real magic is how it figures out what's similar. It does this by finding a center point for each group. That's called a centroid. And then it just groups everything based on what center it's closest to. And its one and only goal, its entire reason for being, is to make those groups as tight and as compact as possible. Imagine you've got a bunch of dots scattered on a piece of paper. The algorithm's job is to draw circles around them so that the dots inside each circle are packed closely together and the circles themselves are nice and distinct. The less scattered the points are within a group, the happier the algorithm is. Okay, I know this might sound a little complicated, but the way it actually works is surprisingly intuitive. So let's just walk through the simple step-by-step logic that makes k-means tick. So first, it all starts with you. You have to choose K. How many clusters are you actually looking for? Then, the algorithm just randomly drops that many center points, or centroids, onto your data. After that, it goes through every single data point and assigns it to whichever centroid it's closest to. Now, here comes the really clever part, the update step. The algorithm looks at these new groups and recalculates the true center of each one. And then, it just does it all over again. It reassigns the points to the new centers, then updates the centers again, over and over until the groups stop changing. That's the whole dance. Now, the algorithm itself is automatic, but it's not quite magic. To get results that actually mean something, the person running the show, that's you, has to make a couple of really important decisions first. And the first most obvious challenge is picking the right K. I mean, are you looking for 3 types of customers, or is it actually 4, 5 kinds of news stories, or 10? If you choose the wrong number, you could end up with groups that are either too broad or too specific to be useful. They just won't make any sense. Luckily, you don't have to just guess. Data scientists have some tricks up their sleeve. A really popular one is called the elbow method. You basically run the algorithm a bunch of times with different values for K, and you plot how tight the clusters are for each one. You're looking for that elbow point on the graph, the spot where adding another cluster just doesn't give you much bang for your buck anymore. There are other methods too, like the silhouette score, but the big takeaway here is that choosing K isn't a guess, it's a deliberate, data-driven choice. And there's one other rule that you absolutely cannot ignore. You have to scale your data. See, k-means is super sensitive to the scale of your numbers. Imagine you're clustering customers based on their age, say from 18 to 80, and also their salary, which could be in the tens or even hundreds of thousands. Without fixing this, the huge numbers from salary would completely dominate the whole process, and the age data would barely even matter. That's why you have to scale everything first, to put all your features on a level playing field so they all contribute fairly. Okay, so we know how it works, and we know the key rules to follow. Now for the fun part. Let's look at where this powerful organizer is actually working, right now, in our daily lives. And the answer is, well, it's pretty much everywhere. In the world of e-commerce, k-means is an absolute workhorse. It's used to slice and dice customers into segments like big spenders, deal seekers, or first-time visitors, which lets companies target their marketing way more effectively. It's also the engine behind a lot of recommendation systems. You know when a website says people who bought this also bought? Yeah, there's a good chance that's clustering at work, finding people who have tastes just like yours. And in the tech world, it's just as common. K-means is used in image compression, where it groups millions of different pixel colors into a much smaller representative palette. That's what makes file sizes smaller, without you really noticing. It's what helps news aggregators bundle thousands of different articles about the exact same event. It's even used in cybersecurity to spot fraud, because a bogus transaction will probably look like a weird outlier, far away from all the normal spending groups.
But its impact goes way beyond that, into really critical fields like healthcare. Researchers use K-means to group patients who have similar symptoms or genetic markers. This can help them identify different subtypes of a disease, or even predict how a patient might respond to treatment. It's a powerful tool for finding hidden patterns that could lead to the next big medical breakthrough.
So when you boil it all down, it comes back to this one simple, powerful idea. K-means finds the natural groups hidden in your data. It does this by grouping points around these central anchors, these centroids, and it uses simple distance to figure out what belongs where. It's all about finding the hidden centers of gravity in a vast sea of information. So, from the products that get recommended to you online, to the news stories that fill your feed, to the medical research that could one day save a life, this kind of automated clustering is quietly working behind the scenes, creating order out of chaos. It really makes you stop and wonder, doesn't it? What other hidden patterns are out there, shaping our world in ways we don't even see?